P1 Successor hybrid Hypercar 2.0 is the next chapter in the story of modern performance cars. It begins with understanding what the original McLaren P1 was and why it became such an important car. The P1 launched in 2013 and combined a twin-turbo petrol engine with an electric motor to create a hybrid hypercar at a time when the world was only starting to understand how useful electric power could be in performance driving. It delivered extreme speed, but also delivered instant torque from the electric motor and better efficiency than many expected from a car with this much power. It became part of the famous hybrid hypercar trio with the LaFerrari and the Porsche 918 Spider and helped to open the door for new ideas in the supercar world. After the P1 production ended, McLaren continued to make fast cars, but none followed the same formula of high-performance hybrid power for many years. Governments added new rules for emissions, new brands entered the market, and customers started to demand cleaner technology without losing speed or excitement. This created pressure for every brand, even brands. Today, the idea of a hybrid hypercar is no longer new, and many companies are preparing new models with advanced powertrains and advanced battery technology. In this environment, the demand for a proper McLaren P1 successor is very strong. Fans want the same feeling of innovation that the P1 delivered in its time. McLaren also needs a new technological flagship to represent the brand in the next decade. A successor must improve aerodynamics, reduce weight, increase efficiency, and deliver an even stronger combination of electric and petrol power. Competitors such as Ferrari, Porsche, Rimac, and Aston Martin are working on powerful cars, and these companies are also pushing the limits of performance. This competition makes the hypercar market very serious, and every company must introduce a car that not only looks fast, but also proves itself on the road and on the track. With all of these changes, the story of the P1 successor becomes more than just a new car. It becomes a sign of how the industry is moving and how McLaren plans to survive in a world that is becoming more electric and more efficient. People expect the next car to be lighter, smarter, faster, and cleaner. It is expected to show major steps in battery control systems, cooling systems, and software integration. This means the project is very important for McLaren and for the hypercar market. Asterisk, the design of the McLaren P1 successor, hybrid hypercar 2.0 is expected to follow the same focus on form and function that defined the original P1. McLaren usually keeps its styling clean and avoids extra shapes that do not help performance. So the new car is likely to look sharp, low, and purposeful. The front section will be shaped to guide air efficiently over, under, and around the body, reducing drag and creating downforce for stability at high speed. The side profile will show smooth doors, large intakes for cooling, and aerodynamic channels that manage airflow from the nose to the rear diffuser. The rear section will be designed to increase downforce without adding unnecessary weight. Active aerodynamic parts are very likely because modern hypercars use movable wings and flaps to balance the car during acceleration, braking, and cornering. The body structure will be made from carbon fiber to keep the weight low while maintaining strength and stiffness. A lightweight body allows better handling, faster acceleration, and improved efficiency from both the petrol engine and the electric motor. The interior of the new car will continue McLaren's driver-focused style with a low seating position and a clear view of the road. The steering wheel will be simple and shaped for proper grip during high-speed driving. The digital cluster will display essential information such as speed, battery status, power delivery, and driving modes. Modern cars also use improved software systems to adjust throttle response, suspension stiffness, and electric motor support. This helps the driver control the car more easily on both road and track. Seating will be supportive but not overly heavy because the goal is to reduce weight wherever possible. The chassis will use a lightweight carbon monocoque structure similar to what McLaren uses in its track cars. This structure increases safety and stiffness and allows precise handling even at extreme speeds. Suspension will most likely be adaptive, meaning sensors will constantly adjust damping to keep the car composed. This approach allows comfort on city streets and stability during track driving. The wheels and brakes will be designed to handle intense heat, especially because hybrid systems produce high torque and regenerative braking can add heat to the braking system. The result is a car that feels advanced but still simple in its purpose. It will not overload the driver with unnecessary buttons or screens, but will give direct control and strong feedback. The design and engineering choices show how McLaren wants this successor to work as a dual-purpose machine for both daily driving and serious performance. Use on closed tracks. Asterisk, the McLaren P1 successor hybrid hypercar 2.0 will depend on a highly advanced powertrain that mixes a petrol engine, with electric power to achieve strong acceleration with improved efficiency. The original P1 used a twin-turbo V8 with an electric motor, and for the Successor, many experts expect McLaren to continue using a twin-turbo engine layout because it offers a good balance between power, weight, and cooling. Some reports suggest that a smaller engine, such as a V6, could be used to reduce emissions and weight, but a V8 is still considered likely because customers in this segment expect high sound quality and smooth power delivery. The electric part of the system will support instant torque, which helps during quick launches and corner exits. The battery will be placed low in the chassis to improve balance and handling. Modern batteries also allow better cooling and more consistent performance during repeated acceleration runs. The electric motor can fill torque gaps that occur when turbos are building boost, making the car feel more responsive at low speed and more stable during high-speed driving. Total horsepower could easily go beyond 1,000 horsepower, because other brands in the same class have already reached that level. Acceleration from 0 to 100 kilometers per hour may be close to 2 seconds, depending on tire grip and traction control. Top speed could go above 350 kilometers per hour, but the focus will not only be on top speed. Instead, the focus will be on how quickly the car can accelerate between corners and how consistently it can deliver power without overheating. The hybrid system will also include regenerative braking, which means the electric motor will act as a generator when the driver lifts off the throttle or presses the brakes. This helps recharge the battery without plugging in and reduces wear on the mechanical brakes. The driving feel is very important for McLaren because the brand is known for steering precision and balanced handling. Software will control the coordination between petrol and electric power, so the driver receives smooth torque at all times. Cooling systems will manage engine temperature, battery temperature, motor temperature, and inverter temperature because hybrid systems create heat quickly when pushed. Exhaust sound will be tuned to provide excitement but must also follow stricter emission rules. Weight will be controlled to maintain a strong power-to-weight ratio, which is key for both track performance and road driving. The combination of hybrid power, strong torque, and efficient cooling will define how the P1 Successor performs in the modern hypercar world. Thank you for watching the video. Please like and subscribe for more content. We appreciate your support.